Hi everyone, welcome to the video series for probability. This is lesson 2. There are 5.1 and 5.2 concepts in here. The learning intention is to list all outcomes for two-step chance experiments with and without replacement. We will look at tree diagrams and tables. So you know you're making progress when you can do these three things. So for question 1, a standard coin is tossed. I want you to list the sample space for this chance experiment. So copy out the question in your book and then pause the video and check in for the answer. So for the sample space for a standard coin is tossed, there are two things that can happen. We can get a head or a tail. So the sample space is the list of all things that can happen. Determine the probability of obtaining the following appearing uppermost. So a tail or a head. Probability for a tail is 1 in 2, 1/2. 50% or 0.5, so they're the three acceptable answers. And the probability of getting a head is 1/2, 50% or 0.5 as well. So the next bit of work, we're going to work out what happens if we toss two coins. What is the probability of getting tail followed by a tail, head followed by a head, and one tail, one head, etc. Before we do that though, let's look at this example. So find the probabilities of drawing two counters from a bag containing 3 blue, 4 red, and 1 white counter. If we draw a diagram, it'll look like this. We've got 3 blues, 4 reds, and 1 white. So with replacements, that means if we take a blue out, if we take this blue out and we put it back in, we replace it. So if we did that, we would have the probability, P for probability, of a blue first and then a blue second would be 3 in 8 times 3 in 8, which is 9 in 64. The probability of blue and then red, so a blue one and then a red one, would be 3 in 8 times 4 in 8, which is 12 in 64. The last example that I have here, probability of white and blue, sorry, blue first and then white, 3 on 8 times 1 on 8, because there's one white one. You'll notice that I'm only using the first one being blue. The probability of red followed by red would be 4 on 8 times 4 on 8. I really want to emphasize the difference between with replacement and without replacement. So without replacement, if we select a blue ball first, but don't put it back in, we would only have 2 blues for the second time around. And notice that we don't have 8 anymore. We have 1, 2, 3, 4, 5, 6, 7. So the probability of getting blue and then blue is 3 on 8 times 2 on 7, which is 6 in 56, and we can simplify that to 3 in 28. So the probability of blue and then red, before the blue ball is taken out, we've got 3 in 8 times 4 on 7. Then blue-white, we have 3 out of 8, and then 1 out of 7. So with replacement is different to without replacement. Example 2 is a basketball that typically makes 3 out of 4 3 throws. List all of the possibilities when 2 attempts are made. So if he makes the first one and then makes the second one, what are the other options that can happen? He can make shot 1 and make shot 2. He can miss shot 1 and miss shot 2. He can make shot 1 and miss shot 2. And he can miss shot 1 and make shot 2. If we put this into a table, it would look like this. Make shot 1, make shot 2, and the probability would be 3/4 times 3/4, 9 and 16. If you missed shot 1, so option 2, and missed shot 2, we would have this one. So 1/4 times 1/4, which is 1 and 16. And the other two options are make and miss. 3/4 times 1/4, 3 and 16, and 1/4 times 3/4, which is 3 and 16. Putting the information in this kind of table helps us to ensure that we get all of the options. If you do this kind of system, you might miss an option. So it's good to have a table. The other way that you can represent this is using a tree diagram. So for the first shot, he can make or miss. Making has a probability of 3/4, missing has a probability of 1/4. If he makes the first one, for the second one, he can make or miss. And if he misses the first one, he can make or miss the second one. So the actual sample space is this list. He can make and make shot 1, make shot 2. He can make and miss. He can miss and make. He can miss and miss. And then to work out the probabilities, when we go along the branch, we multiply. Later on, we'll get to the point where we add 2 branches together. So if we were finding the probability that he makes 1 and misses 1, we would add these 2 numbers together. It would be 6 and 16. But we'll get to that in a future lesson.